This is Lecture 17 summary by Maegan, Alyssa, and Melissa. So first are phase diagrams. Phase diagrams specifies the physical state of a substance as temperature and pressure varies. Each region that is separated by the lines displays the conditions in which a particular phase is stable. So there's a triple point right here, where the temperature and pressure of all the three phases, liquid, solid, and gas, of the substance coexist. And there's a critical point where the liquid and gas line ends, and both phases have the same density, and the distinction between the two disappear. And there's a supercritical fluid, somewhere in between the gas and a liquid, and there's no strong interactions between the molecules. It's dense as you would expect from a liquid as well. And this is a phase diagram of water, and it's unique from other phase diagrams, and this is because the density of water as a solid is less than the density of liquid water, and because of this there's this negative slope right here, meaning that the temperature of which ice melts would decrease as pressure increases.
London dispersion forces. Van der Waals forces describe the attraction between molecules. This attraction is very weak when talking about a singular atom, but with molecules with many atoms, the attraction increases. The van der Waals interactions hold things together, and that connection is disrupted when boiling occurs. When a substance goes from being a liquid to a gas, the molecules separate. The thermal agitation that the molecules experience from high temperature separates the molecules. They go from being a liquid to a gas. The boiling point can tell us how strong the intermolecular interactions between two molecules are. The stronger the interactions, the higher the boiling point. Viscosity. How easily a substance flows is described as viscosity. Stronger molecular interactions will amount to a high viscosity, since they're being held together more. Examples. Honey has a high viscosity, so it would flow slowly. Water has a lower viscosity than honey, so it would flow faster. The shape of the molecules also play a role in the viscosity of a substance. Long molecules can get tangled, which makes for a high viscosity. Spherical molecules can get past each other easily, which makes for low viscosity. As seen in the table, as the molecules increase in atoms, the viscosity increases as well. If a molecule has a viscosity less than 1, then it has a lower viscosity. If a molecule has a viscosity higher than 1, then it has a higher viscosity. Since there are more atoms interacting, there are more van der Waals interactions, which holds the atoms more closely together. This makes it so they can't flow as easily. Dipole-induced dipole interaction. Oxygen and water do not interact much, but sometimes there are interactions. The water, with its dipole moment, can induce a dipole moment, and the oxygen's partial positive interacts with oxygen. Water has a strong dipole moment, while the oxygen is nonpolar, but the oxygen can be polarized by this dipole-induced dipole interaction.
Dissolution is a process of where a substance, such as a solid, comes into contact with a solvent, dissolving it to make a solution. For ionic solids, these ions go into the solution because the cations interact strongly with the water molecules, creating hydrogen bonding. This creates ordered salvation shells. Depending if there are favorable conditions, some dissolution processes can release heat or consume heat. There will always be limited solubility, and if this limit is reached, there is solution equilibrium. And dissolution processes will always be dynamic, which means that there will always be new molecules being dissolved or precipitating. Solutions and solubility. A solvent is a substance that is capable of dissolving another substance. This contains the largest number of moles present. A solute is a substance that is being dissolved to create a solution, and the solution is a homogeneous mixture that contains two or more substances. And then the solubility limit is how much of the substance can be dissolved. Trends in solubility. Miscible are liquids that are mutually soluble in any proportion. Strength in numbers of interactions among solute particles with the solvent molecules determines solubility. Miscibility can also go down. In ketones, they become less soluble in water as carbon chain increases, which causes them not to be able to create hydrogen bonds. Molecular solutions. Nonpolar solutes interact with nonpolar solvents because of van der Waals interactions. For example, heptane and octane are both nonpolar components of gasoline, which creates miscible liquids, and they do not prevent any polar interactions from occurring. Mole fraction is defined as the moles of the component substance divided by the total moles of solution. The mass percentage is defined as the mass of a solute divided by the mass of a solution times 100%. Molality is defined as moles of a solute per kilograms of solvent, and finally, molarity is the moles of a solute divided by the liters of a solution.